So let's find the Laplace of this piecewise function. So we're going back to that definition of a Laplace, which says to find the Laplace of f of t, it's the integral from 0 to infinity of e to the negative st times f of t dt. So in this case, we're going to have to create two different integrals. One will go from 0 to 3, and that's because the first piece is defined between 0 and 3. And that first piece, our f of t, will take on that value of 0, between 0 and 3. And then that second piece is defined from 3 to infinity. And it takes on the value of 2. So you can see how we're having to split this up, because we have a piecewise function that's defined in terms of two pieces. If we had 3 pieces here, then we would define this into 3 pieces, and so on. So this guy, if we were to integrate and then evaluate that definite integral, that guy's just going to be 0, so I'm just going to mark it out. So we really just have to deal with this guy. I'm bringing that 2 out. So to integrate this, we would do a u substitution. We need a negative s here, so we can compensate with a negative 1 over s out here. And when we integrate e to the u, we're going to get e to the u. And we are evaluating from 3 to infinity. So I'm going to rewrite this guy. We can think about it as 1 over e to the st, going from 3 to infinity. So if we were to think about plugging big numbers in here, then that denominator is getting larger and larger, which means that fraction is heading to 0. So we have negative 2 over s times negative e to the negative 3s. And we're going to have 2e to the negative 3s over s as our final answer. So this would be the Laplace transform for this piecewise function.